Okay, welcome everyone to another robot party. I believe this theme for this robot party is robots sensing the world around them. So it will be cool to hear what everyone's robot can do in that regards. Um, so last robot party was pretty fun. This one will be too. We have a special guest, Camille, who's here with us today. So it will be cool to hear her thoughts on robots, technology, and also what she's been up to this summer. Um, what else in terms of announcements? Next robot party will most likely be in a month from now, so it'll give you plenty of time to build up on your robots for then. And behind me is my robot, which is all in pieces, so hopefully that will be true for this robot as well. Okay, so with that, I think first what we'll do is we'll dive into actually, does anyone have like a working robot to show?
I don't have anything new.
Okay. This is funny because it's like robots are never working.
This is new, but it doesn't work.
Alright, Robot Goldfish, why don't you go ahead and show us your robots first?
Oh, goody. Now, this is an idea I had. Hang on a second. Let me lock my mic on. Okay, this is an idea I had. It's RG2 has one-way wheels on it, and this uses a 3D printed one-way wheel. And the idea is that so people could build it themselves, and it has 3 wheels. Since
a one-way wheel, how does that work?
Well, the wheels only turn in one direction. So that means that when the third wheel moves it back and forth, one wheel locks, and it rotates on that one because the other one moves forward, and then it locks and it rotates on that one. So you have one motor, and it can move forward and turn around in its place.
Wow.
It's the same way RG2 works. It's just that these wheels are taken off a copy machine, and not everybody has those. But I was also talking, I can't remember his name, about doing that. He came up with a better plan for the clutch. And so I'm eventually going to do one with a printed clutch, Robot Goldfish, but I'm going to move it so the wheel is going to be in the front and the 2 rollers are going to be in the back, so that way he'll be able to turn around from the edge of a table.
Nice. How is it going to sense the edge of the table?
It has a little arm that sticks out with the sensor on it. That way it doesn't have to be right it doesn't have to be in the corner. It's like the next one's also going to have whiskers, so that it'll bump the edge before it won't be able to turn around.
Gotcha.
Now I have to build it.
So for the wheels on that robot, they were all 3D printed?
Which one?
The new one. MR3.
Oh yeah, the whole thing is 3D printed.
Wow.
Except for the servo and some parts scavenged from the insect box Hexa we had at Maker Faire.
Cool.
Other than that, I've been working on building a Root 2 CNC machine, which it's mostly 3D printed parts. It's really nicely designed. And I converted my printer to 1.75 filament, and I'm just getting it working today. But that's about it.
Cool. Thanks for showing us your robots.
Well, I haven't been as active as I should have been, and people are complaining about websites not having anything new, and it's because we're not putting anything new. So I've got to get my button gear. So if I get my button gear, people make comments, and maybe that'll get some momentum.
Sounds good. All right. Let's go to Camille now. Because it looks like you aren't driving now, so that's good.
Oh, yeah. I was in a weird parking lot, so I moved.
All right. So tell us more about what you're doing in technology, just in general.
Cool. So I'm out here in the Bay Area, I'm working in Palo Alto at HP, and I had the opportunity to work on some really cool artificial intelligence for some robots I'm working on. So we got some telepresence robots down there that attend meetings regularly for our different sites around the world. So people come in and attend meetings, but it's not able to actually navigate up and down stairs or go into conference rooms on its own. So my job right now is to create a simulation using ROS, which is called Robot Operating System. I don't know if everyone's heard of that. But what we're going to use that to basically allow a telepresence robot to navigate to a conference room on its own and then open the door on its own and walk in. So that's the idea. And the idea is if I can simulate it with ROS, because ROS has a really powerful simulator, I can put it onto a physical robot. So that's where I'm at right now. It's involving some point cloud libraries and then some other, basic algorithms for arm manipulation. But yeah.
Wow. Okay.
It is.
That's so much stuff. Would you be using so? Right now you're in simulation mode, but
yeah.
Have you given any thought to what the actual hardware will be?
Not a lot. What we're hoping is that we can find, if I have to build it, that's not a big deal, but we have one that another site's been working on. It has a little code name, but they've built a stackable, basically, robot where you can stack different things on it and change it. So, there's a module with just arms, and you can take that off if you wanted to and just have a telescoping part on it. So, that's been a lot of in-house stuff using other things that I'm not aware of because I wasn't on that side of the project. But they have some prototypes being built on our side in a different team. And so I'm seeing if I can get the programming to work, and then I can work on integrating it into an actual hardware.
Wow.
Yeah.
That's so cool.
Yeah. I've been on the project for about 2 months now. And I actually did not know ROS beforehand, so I've been doing a lot of learning on the fly, which has been fun.
What would you say has been the most interesting or useful thing that you've learned so far with ROS?
Oh, that's a good question. Well, one of the things I don't know if everybody knows Robonaut, which is one of NASA's robots. It's actually programmed on ROS, and Robonaut's actually in the space station right now. And so what I've learned is that I kind of learned the simulation practicalities of ROS, which is really interesting because, it's one thing to have a physical robot, and we actually have an example of this. In Boise, we have a robot arm that's so powerful, it knocks people out, and you have to, have a really wide berth. So,
wow.
So I kind of learned, hey, simulation, having the ability to do some really high-level simulation is going to be really useful because I don't have to waste the time killing people in the process. So it's been awesome. So Robonaut, the reason why I brought up Robonaut is I can actually bring in Robonaut's files and simulate Robonaut just as good as they do on NASA. And so that's been really interesting. Yeah.
Wow. So Robonaut is also open source in a way?
In a way, the Gazebo, so the simulation is called the Gazebo, right? The software, and so they have the Robonaut stack available to download on GitHub and to use on Gazebo. So you guys can work with NASA's robot. And NASA does hold open competitions to do things like improve Robonaut's vision and things like that. So they are having open competitions where you can kind of work on the future technology of Robonaut.
Wow. And in terms of vision, what you mentioned about point clouds. How are you generating that point cloud? Like, what type of sensor are you using? Oh no, is it frozen? No. Oh, man. No. Oh man, I think Camille got frozen. Shoot. Anyway, that's so cool, the robot that she's working on, all in simulation so that it doesn't, so that you can figure out where the robot will go wrong before you actually use it. Alright, well, hopefully she'll be able to join. Yay, she's back!
I guess because I'm in the car, my phone decided to overheat. So I might not be back for very long. But you were asking me about vision. Is it okay if I hop right back on that? Or?
Yeah, please.
Okay. So for vision, we're using things, so a lot of people use Kinect, like the Kinect RealSense camera.
Yeah.
Not RealSense, sorry, the Kinect camera. I, though, want to use Intel RealSense camera because I used it on a former project of mine where I was working with a robotic hand, and I used its vision, and that seemed to work pretty well. So I'm thinking about using the Intel RealSense camera and getting the information and creating a point cloud library from that.
Nice. So, switching gears now, hopefully before your phone overheats again, where do you think robotics in the future is going?
Oh, I totally predict world domination. That would be totally fine with me. World domination. People like I'm more of the opinion that it's way too interesting to not see how far we can push robotics and do whatever they can do to just let it go because they're afraid of world domination. So I think robots are going to be able to do everything and anything, but it's going to be really hard for them to do it. So that's my comfort. You know, a robot is going to take 10 times more brain power for a robot to do what we can do. So they're never going to be as smart as us, but I think they're going to be able to do pretty much everything. So I'm okay with that.
Nice. What advice would you have for people just starting to get interested in robotics?
Just try something. Try what's closest to you, is what I say. Try something that's super close to you, and then don't let anything stop you. So if you have an Arduino nearby, then use an Arduino. But if you only have basic programming, then use the basic programming instead, and just see what you can do to make the first steps into it.
Nice. What would your dream robot project be?
Say it again?
What would your dream robot project be?
Oh, my dream robot project. I think maybe creating the next robotic arm on the International Space Station, because that was my first dream, is to work in space and to do stuff with robotics in space. So I know that the robotic arms on the International Space Station, and even the International Space Station itself, is getting old. And so I think that would be really cool to build something that big for a space application, that scale.
Yeah, nice. All right.
That would be really cool. Thank you.
Well, thank you for joining. This has been great.
Yeah.
Where can people find you online and follow your adventures?
Oh, yeah, I'm really active on Twitter, so at Nikki Mill. And then I also blog at hellocami.com.
Nice. Cool. Thank you so much. And yeah, great. Thanks. Yeah, if you have to go, then just feel free. But if you want to stick around, you can stick around.
My phone's gonna overheat. Thank you. Awesome. It was nice to meet you.
Likewise. Keep up the good work.
Thanks.
All right. Hopefully her phone won't burst into flames. um, okay. Who wants to share robots next? All right, Stephen, do you want to share what you've been working on next?
Hi, yeah. Can you hear me?
Yeah.
Yeah, pretty much what I was working on before. So I'm still in simulation. What I have on my website looks similar to what I had before as well. A lot of what's under the hood has changed and been sort of added to and tweaked, and I'm on to kind of the next phase now. What I had up there before, so this is for a multi-agent robotic system.
Yeah.
And I've been speccing out hardware that I want to buy because I want to start building miniature, like a miniature swarm, I guess. And initially I want to build, maybe 3 or 4 robots identical to be able to test out some of my algorithms. So I've been speccing out hardware to build like 1 or 2 cubic inch like miniature robots to test some of this stuff out with. And I've just started working on some neuroevolution stuff. So I've been reading, and I'm continuing to read up on neuroevolution.
So what is neuroevolution compared to normal evolution, or so-called normal evolution?
So the approach, really, it's the idea that you take evolutionary programming and neural networks, so that you can have neural networks that can dynamically learn, like in real time. And it's also a way to modify neural networks on the fly too. A lot of times neural networks are built, and the network itself, you have to, with your design up front, you typically design a neural network with all of the nodes and stuff that are pretty much fixed. With neuroevolution, that allows for not just changing the weights of the nodes within your network, but also the structure of the neural network too. So it's a combination of evolutionary programming plus neural networks for real-time systems, and for systems that can sort of learn, in a closer fashion to how we might learn, compared to what we have currently. So it's been around for like 20 years or more, but there's a lot of research is going into neuroevolution now. That last 10 years, and I've been reading papers from the last like 5 years even. A lot of new research and study going into this. The University of Texas actually has their whole department. They've done a whole ton of stuff on neuroevolution. So I think it's a technique that will work well with this sort of multi-agent robotic system that I'm building, and that I'm writing algorithms for at the moment in simulation. So that's just kind of what I'm working on right now, basically. A lot of reading and learning about neuroevolution, and starting to build out algorithms using that approach, so that I can basically teach. I don't want to hard code my robots within this group the way that the robots connect and communicate and interact with one another. I don't plan on hard coding that. I have a set of rules. I sort of came up with a set of rules that I can use, that can be used as part of sort of evolutionary learning. And then I'm going to use those rules to apply to some algorithms that I'm hoping to sort of develop, so that the system could learn itself.
Where do you see this eventually being applied?
So sort of anywhere. I don't really have any fixed sort of area right now, but an autonomous multi-robot system. And sort of going back to similar to what Camille was saying too, the system is also, it's a participation system. It's a system that I've come up with an easy way for allowing humans to sort of drop in and drop out with participation and control of the system. So you can have fairly simple units within the system that can do a certain number of things by themselves or as part of a group. But I think it's important that, at least for right now, with where technology is right now and our knowledge, that by allowing humans to participate in these systems too, then we can use the human brain, to perform functions with the system as well, and to sort of partially control the system. So it's an autonomous / semi-autonomous system is what I'm building. So then you could use that for anything. I think of things like search and rescue, environmental monitoring of some kind, whether that's in the air or in the ocean, that sort of thing.
All right. So yeah, robots for a good cause in that regards. Neat.
Yeah. And remotely sort of accessible too. So I like the idea that someone on one side of the planet, could access this system, even in a participation sense. So they would have a certain amount of control over like a follower robot, for instance, to be able to kind of look around and stuff, that sort of thing.
All right, great. Well, it'll be interesting to see, again, hopefully soon, like what changes in the back end can like result in the front end, like the interactive web apps that you've made, so that hopefully we can see a new version soon. That would be great.
Yeah, once I start to get some updates to my website, I'll start to post those as well as I build out these algorithms, and hopefully at some point I'll actually have physical hardware I can show off as well.
That would be cool
when I start to get pieces, yeah. So
wow.
I have a general idea of what parts I want to use and what I want to build, at least for initially testing the system. I want to use fairly basic components.
Maybe you should try Robot Goldfish's new robot, one with the locking wheels.
Oh, that's right, yeah.
It doesn't actually work because the wheels are too narrow, but I was thinking of making a 1-inch square one with wires like an insect leg. So you'd have one motor and 2 little wires that would hook into the ground.
Yeah, that sounds pretty interesting. I need to actually get more into like 3D printing and stuff like that myself. I tend to buy components and stitch components together. So it would be kind of nice to get into 3D printing and being able to design and print my own parts at some point too.
All right. Thanks for sharing your project update.
Yeah, hopefully I'll have more soon or next time.
Great. We look forward to it.
Oh, and also congratulations on your Kickstarter campaign too.
Oh, yeah. Thank you.
That's very cool. Yeah. And I just wanted to mention very quickly, you inspired me slightly because I moved to a new place in the last 4 months, in the last month. And we've got a tiny beach area down along the Hudson River. And I was down there about 2 weeks ago, and I happened to notice all of the debris that's on this. It's a really tiny beach area. And it's interesting because all of the park area around there is very clean and well maintained. But this slither of beach that I've noticed not many people use, but it seems like a perfect place for kids and dogs. But when I took a look, there's just a ton of rubbish down there. Just you can't notice it from afar, but lots of rubbish, pieces of glass, pieces of plastic, and
wow.
all sorts. And I ended up snapping like tons and tons of photos, and it reminded me. You kind of inspired me to do that with your project and with what you were doing with your field testing. So yeah.
Wow, that's
hopefully
great.
We'll have a bunch of robots that are, one by one cleaning up our little beachfronts too.
It would be great to see those photos at some point.
Yeah, I'll post them somewhere. I'll send them some to you or something.
Yeah, that'd be great.
I was surprised at how much debris and rubbish there was there, and I'm not sure how much of it is dropped versus how much is washed up from the currents. Yeah, so I'll share those with you.
What were the sizes like? Were they varying between like cigarette butts to like things more like plastic water bottles?
Yeah, exactly. They were tiny slithers of things, tiny pieces of plastic. You're exactly right. The size of sort of cigarette butts and tiny pieces of glass, all the way up to full-size plastic bottles and
wow.
Soda cans and that sort of thing. And you could readily see like some bottles and soda cans, but it's only when you get up close to the environment, to the sand and stuff, that you notice how much debris there really is, just small, very small pieces of debris, but just lots of it.
Yeah, and it's really difficult to pick up that stuff by hand.
Yeah, I would imagine, and I'm interested to see how your project progresses too with your field testing. It almost seems like you have to dig and sieve or something. I'm not sure.
Yeah, that's generally what the process will be, but a robot will be doing it. So it's a repetitive and redundant task, but a robot's doing it. So
and hopefully, I tend to think of things like that too, the idea that if we can hook up a bunch of robots, like have a multi-robot system that can do that as a collective too.
So there was an article there's an article recently about how some researchers used LiDAR to scan a beach, and they were able to detect pieces of debris. Of course, like, the debris was sort of on the scale of like the water bottle size, not cigarette butts. And I was wondering, Camille, do you think that with the Intel RealSense that would be possible, like in the outdoors?
Well, it depends.
Oh my gosh, you're driving.
I am.
Oh my gosh.
No, I would just say that the Intel RealSense did do a good job of object recognition when I was working with it. But it would just kind of depend. I use a lot of the SDKs already in it, so it would just kind of depend on what's developed for it, because it's not something that's being super developed right now. At least not on the one that I was using. Mine was kind of low tech.
Okay, cool. Thank you for the live report. Okay.
Yeah, you're exactly right. It's very easy to pick out with existing tech, like large objects, but it'd be interesting to see how we can, build something or use tech to be able to detect, tiny pieces and to be able to differentiate that from just, regular stones and rocks and sand particles.
Yeah, that's going to be tough.
It's a very tough, difficult challenge, but hey, it's doable, I think.
All right, let's see what Michael has. Robots. This is interesting.
You asked for a working robot, and most people say 3D printers for robots.
Oh my gosh.
So this is my new 3D printer I've been working on, getting to work. So.
Can that run off of any type of batteries?
It probably could.
Nice.
But the one thing I'm working on, I don't know how well you can see it. These are,
a gripper.
These are based on. You remember Shibata?
Yep.
Here, you met him at Robo Games. This is based on his design, so I'm 3D printing these out so that I could send them to him. They use the Robotis XL320 servo. It's a $20 servo. So the idea is to add these to the Bioloid robot, maybe the Darwin OP, and then use the smaller servo to actually actuate the. Probably hard to see, but basically the servo will do this.
Cool.
What I'm testing out this is sort of like NinjaFlex.
Oh, wow.
So we're thinking maybe since these not sensors, but there's not really any sensors to these grippers to keep them from crushing things. Using the flexible plastic filament will keep them from doing damage to an object that we try to pick up. So we're just kind of experimenting with different ideas of how to add cheap grippers to robots.
And
maybe something like to your robot, maybe. Like Shibata wants to open source all these so everybody can download them and play with them and get them to work, give them feedback as far as design and so on.
What did you? Oh, sorry.
No.
What did you design it in?
I've just been playing around with Onshape, doing some modifications on Onshape. I think Shibata uses Inventor.
Okay.
The original designs are his, used in, like I said, Inventor. I'm pretty sure that he uses that. So just kind of playing.
What print speed did you use for that flexible filament?
The my little printer here, the M3D, is really slow printer. I'm doing these are 250 microns with very loose infill, like 30% infill. Doesn't really have a speed setting. I mean, well, actually, what it does, it based on the filament you're using. Here it is. Based on the filament you're using, you basically type in. I don't see if you can see these. You type in these 3 letters, and then it picks the temperature and the speed, and does it all for you. So, and this is the flexible stuff. So it actually extrudes at a higher temperature than their normal PLA or ABS, and then it picks the speed for the extrusion. But like I said, it's not slow. I think this part right here is like a 4-hour part. So
Okay.
I'm sure that
it does take long.
anybody else you can download. I mean, you probably could do a little bit faster than that. But
What size of what size of objects can that gripper pick up? Gripper use.
let's say let's see if I can find something that anybody would know. You really don't know what size the servo is. Let's see. I'm trying to find something that's, well.
What's a common object for robot builders?
See, this kind of gives you an idea, the size.
Okay.
Like I said, I think he's got them online. I'll make sure he's got all these. He's got these online, like a Thingiverse or something, so people can start downloading and printing them out.
Nice.
I'll talk to him tonight when he wakes up. But this is kind of his. I don't know if you've seen some other gripper designs that he's done. This is very similar. He likes the 3, like almost like a thumb and 2-finger design. This is what he usually does. I haven't done a lot of modification to this because he does a really good job of designing things. So I just been playing around.
If you were to add sensors to it, what would you add?
It'd be some kind of force sensors here on the tips and the inside here, so that when you're closing in on an object, you can start getting the force. So, like, if you're closing on something and it's really hard or something or whatever, you can start telling how much force is on the pads and then get feedback on them. So that's yeah. So you force sensors, maybe touch sensors here on each of these prongs, maybe on the tips.
Cool.
But as soon as I get 2 nice pairs printed out, I'm gonna send him. I'm gonna send him in send a package to Shibata so he can play around with them and see if he likes them or not. And then we'll kind of collaborate back and forth. Maybe try to redesign and make them a little bit better, easier to 3D print out.
That's pretty exciting, collaborating from different corners of the earth.
Oh yeah, I mean I know the internet's been around for a long time and emails have been around for a long time, but Hangouts, Google Chats, Facebook, all such social networking. You can easily. I can text him all the time when he wakes up in whether he's in Japan or Korea. We can text. When he wakes up and when I get ready to go to sleep at night. So it so makes things so much easier. And then with sharing sites like Thingiverse and other places, you can just upload your designs and get feedback from all kinds of people from all over the world. It's so cool how the social networking, internet, the collaboration that's going on, open sourcing of projects and stuff.
Nice.
Cool.
Okay, well, it'll be cool to see this on a robot one day. And thanks for sharing.
Yeah, no problem.
All right, next up we'll go to John. What robots have you been working on lately? The ceiling.
Yep, that's what. I'm doing this on my phone and it's giving me trouble right now. Okay, there we go. So this is my latest robot.
Oh, it's frozen. Oh, there you go.
Okay.
Okay.
So this is my latest robot. I was just assigned a cubicle at work, which has got a great big huge expanse of nice flat desk area that I will never use. So I am building this to run around on that desk. It's got the 4 or the 6 corners of the hexagon have got these 2 little, each one has 2 little holes in it for an infrared emitter and detector, and those will be cliff sensors so that it won't drive off the edge of the desk. And it's got micromotors. All the electronics are still on the breadboard right now. I still need to. The one thing I have done that's kind of cool about it that I'm a little bit proud of is I built, let's see if I can get it, this.
I don't think we see it. Oh, now we see it.
That is, this side of the board is 6 constant current supplies to supply the infrared emitters, and this side of the board is 6 voltage dividers, so I can take the detector part and run them into an analog input. And I'm using a Pro Trinket as a microprocessor. So this will do all 6 of those sensors on one little surface mount board. And I designed this board and etched it and soldered it by hand all myself. So I'm a little bit proud of that.
Wow.
That's the only electronics in that I've done. I bought everything else.
So how does it, like, what exactly is it sensing for current? Like, through the whole robot? Or just the IR sensors?
You broke up. I didn't get your question.
Sorry. What are you using the current sensors for on your robot?
Oh, well, the best way to drive an LED is with a constant current source.
Mm-hmm.
So, like I said, half of that board is 6 constant current sources to drive the 6 infrared LEDs on the corners. And then the other half is the voltage divider, so I can turn the detectors into analog inputs.
Oh, nice. Yeah. Okay, yeah, I think I get it now, yeah.
So that's what I'm working on right now. That's one of 3 robots I'm working on right now.
Okay, what are the other 2?
Well, the other 2 are my big airplane. Here's the electronics for it. This is the automation electronics. This is what's called a UDB5 board. It's a 9-axis degree of freedom autopilot board. This is a GPS. This is an open log.
Oh, sorry. For your
Go ahead.
GPS, are you using only the North American satellites or also the Russian satellites?
You know, I don't have a clue.
All right.
So I'm using whatever this thing receives.
All right. Cool.
So that's the electronics for my second robot that I'm working on. The airplane is too big to get a picture of. So come with me now over here and I'll show you my third one. I thought we were going to do robots on parade or something like that today, so I got all my robots out ready for the parade.
Oh, that's great. Yes. Awesome. Oh my gosh.
So this is the one I'm working on now, and it's a Goodwill RC car, and I'm working on retrofitting the steering with a proportional servo, and it's got an RC speed controller in it, but that's about all the electronics I've got worked out on it now. But so it's in very early stages. So that's the second one that I'm working on.
Nice.
And actually, I'd say that I'm working on 4, and this is my 4th one.
Man, it's all metal. That's cool.
One of the surplus places that I shop at a lot had these metal Maker Beam kits, very, very, very much on sale. So I bought a bunch of them, and I just playing around, put that together.
How do you find the power transmission working with just like that? Looks like a G2 timing belt, right?
Yeah, I think so.
Does it work well?
I have not tried it yet.
Okay.
I've had them powered up, and it seems to work okay. The one problem I've had with this particular design is the angle right here on the drive wheel is not sharp enough, and there's not enough teeth engaged, so it will lose steps because there aren't enough teeth engaged. I need to change this design somewhat and make that so there are more teeth engaged on the drive shaft. But so those are the 4 robots I have in flight right now.
Wow.
I don't really have anything interesting that works.
All right. Cool. Well, thank you for showing us all the robots, getting them ready for the parade of robots. That's great. Cool. Does anyone? Yeah, thank you for sharing the robots. Great. Does anyone have any other robots to share or show?
I think he's holding a ball-bearing mouser. I saw those advertised at one of the surplus places I shop at.
Wait, what? Where?
Oh, Michael had a self-replicating ball-bearing rodent control robot. I've seen them advertised at surplus houses.
Nice. I guess I could show a bit of what I've been working on. I wasn't expecting to show it, so bear with me here. I'm like attached with headphones and I can't reach it on the desk. No. There we go. Okay. Okay. So this here is the new base of the robot. And as you can see, it's composed of 3D printed tile pieces that are then screwed together like that. And then on each of the pieces, there's at least 5 mounting holes. And so this is like the basis of the modularity feature of the robot. And then what's really fun is, well, you notice the robot can't really, it's like, it's not even a robot right now, right? Well, there's this feature where you can slide in and out the drive modules. So this here is one of the drive modules where it has a 65-to-1 motor on the front end and then skis on the back end, or maybe reversed. And so you can just slide this into the base like this, and then lock it with this piece. And then now you have the wheels on the robot. And so the idea is that if you're in the field, say you bring a backpack with you that's filled with robot tools or equipment, then you'll be able to swap these in and out on the fly. So say if you need wheels that have more torque, then just swap them with those ones. You also may notice that we did switch from the dynamic tilt to just a static suspension, really, for these wheels. And that is because when we were testing the dynamic tilt, we recognized that there was this odd thing that happened where each of the struts for the wheels would sort of splay inwards when it was turning, or even just going forwards. And then when it was turning, then it would really affect how well it could turn, especially in the wet sand. So we needed to reduce the amount of variables in the robot in order to test it specifically for the turning. And so this is along the ways of thinking about that. Yeah, just been working on that. This was the first prototype piece printed out of the sweeper. So you know it's in development because this is the piece that we printed out. And this will be running on a relatively fast motor, so that's pretty sweet. I'm really looking forward to testing this. It's just that there has to be a lot of modeling done for the sweeper mechanism. Apart from that, one of the collaborators got the environmental sensors working and logging data. So we can now attach that onto the robot and get data whenever we're roving around. So things like UV index, temperature, and humidity. We'll probably add on one for like altitude and barometer. We have one for dust, but it never works. And pretty soon we'll get GPS going. Our next field test is next week, 20th. So by then I'm hoping that the new wheels will be on the robot. We'll have a new arm and an intelligent claw or a scooper. So yeah, just it's interesting because it's always iterating over and over again and like building on what you see as successful and changing the things that weren't as successful.
Can I ask a question?
Yeah.
Okay. So when you talked about the sensors, that kind of reminded me of a project one of my colleagues is working on. So do you have any plans to like make that sensor, those sensors, practical? Like, is there like an application you're going to, or are you just looking to be able to get the information and maybe transmit it somewhere? So maybe like something where you can start detecting patterns or start being able to make decisions on maybe how to influence the environment that it's in.
Yeah, that's a really good question, and we've been talking with some environmental organizations about that because, like, as roboticists, we're not really sure ourselves. But one of the things that we can do eventually when we get the GPS data added onto the environmental data is like create a heat map of the certain points and then where data is changing. So data, like the sensor shouldn't change that much as we're navigating along in like just an afternoon, because like that's not the pace of nature. Pace of nature is over the course of seasons and many years. But the interesting thing will be, like, there was one field test that we did where we took the sensors like near the water and then in the shade, and noticed that there were differences just within like 20 meters. So I think there's a lot of discoveries to be made. So the practical application is unsure of yet, but by having it on there, we might be able to figure out one. That's a good question. Thank you. Let's see.
Are you using the Russian satellites for your GPS?
No, we're not. And we should be, because there was this one beach that we went to, and we couldn't get a fix. So that was so bizarre. But a friend is working on finding the modules for that. It goes by the name of GLONASS. So yeah, that would be great.
And for your next field test, are you field testing like in the same location, or are you switching locations?
Sometimes we switch locations. It can be kind of difficult to manage logistically, because like there is a beach that I would want to go to, but we went to once before, and it took one volunteer like 30 minutes to find us, and another volunteer was never able to find us. So we typically try to go to the beaches that are like a bit easier for volunteers to find us or to join in. So usually just switching between like one or two beaches or so. But the mission pilot, which will be like the big one at the very end of summer, that will be on Toronto Island, which is a ferry boat rides away. So that would be interesting. Much greater chance of people getting lost for that one.
And you said you had spoken with like local like environmentalists. So are you sort of working fairly closely with them like during your field testing as well, or like when you get toward the end of field testing, will you be sort of reconnecting and working with those same folks again?
So when we get towards the end of the mission pilot is when we'll be really reconnecting with them again. They've been like really helpful by being enthusiastic actually about technology and innovation, which I was surprised about, because I would have expected they would have been like, oh, we shouldn't do this because like it's technology, it wouldn't it would be more damaging to the environment. But they're really enthusiastic to see how well the sweeper will do for picking up the smaller size debris. There was a field test that we went to recently where we had another instance of birds inspecting the robot, and it's really interesting because the birds come along and they just are so curious about the robot. They just walk up to it and like look at it and inspect it. They're not frightened by it at all compared to humans. It's just so interesting to me.
Forgive me if everybody else knows this, but what kind of processor are you using, and do you have your computing power on board or off board?
Yeah, so on the robot, like Bowie #1, the previous version, it used a Teensy LC for the motor core, and then for the sensors and comms core, it used just a standard Arduino. And then the control unit was just controlled with the XB Series 2 using a standard Arduino. And for that version, the environmental sensors were logged directly onto a computer, so it was attached via a USB cable. For Bowie the second, it's going to have a Teensy 3.2 for the motors, Teensy 3.2 for the sensors and comms, and an Intel Edison on board so that it can log the environmental sensors and the GPS data. Yeah.
Why not the Raspberry Pi? What's your pros and cons about the Edison or the Raspberry Pi?
We've been having a really difficult time with the Pi, just trying to SSH into it without a screen. It is the most annoying thing in the world. I don't understand why it's so difficult. Like, you need a screen to, like, even boot up properly. Maybe we're doing something wrong, and if so, please someone let me know, because that would be great. Yeah, based off of that, the Intel Edison is just easier to run headless.
Yeah, I've read around. I'm in the Arduino XP camp at the moment, but the Edison is something I'm interested in using down the road. And I did a lot of research too, just to find out what other people are using out there and comparing between like the Edison and the Raspberry Pi. And yeah, the Pi certainly seems like it's more of a sort of general computing tool, and people aren't really using it for robotics, whereas the Edison is really designed for those sorts of applications, I think, from the ground up, where the Raspberry Pi wasn't designed from the ground up for those purposes. So maybe that's why there's more of a struggle there with that.
Yeah, maybe. Have you read anything about the Edison versus BeagleBone Black?
No, not the BeagleBone. I came across something recently. Oh, I actually have it here. Something I saw, maybe it was posted on like a tech website, Nexting Co. or Nexting Company's $9 chip.
Oh, yeah.
Yeah, I don't know much about that. It seems fairly new, but it's super cheap. So I'm sort of tempted to maybe use that initially, just because it's so damn cheap. Before going with something more expensive later on.
Yeah, I think I read about that. It's a Wi-Fi module. It's like Arduino-based Wi-Fi module.
The Arduino 101, the one that has the new Intel, that little smaller chip on it, has Wi-Fi, accelerometer, and Bluetooth built into it.
That's right. Yeah, you can use XP with it too, and that's sort of what I've been using. But yeah, it's got like Wi-Fi and Bluetooth and everything all built on. You're getting a lot of chip for like $9 from the looks of things. So yeah, for prototyping at least, it seems like it might be worthwhile checking out.
I think it's also the same chip on the Edison, but I may be wrong on that. On the Arduino 101 and the Edison are very similar, both Intel.
There's also
a tidbit I picked up from the XP people at a Maker Faire is apparently there's two-way audio channels on the standard XP chip. They were using them as like walkie-talkies. So there's another analog channel that you can use if you want to use it for telemetry.
Ooh, sweet.
So you can do sort of concurrent bidirectional communication with it then?
Yeah, apparently they just had some standard XPs and they were wired up as walkie-talkies across their table.
Oh, wow. Oh, that's cool.
Nice.
You're not going to run into this, but RoboGames XP doesn't work very well. All the phones and everything, it seems like everything's flooding that, and it's
Would that be on 2.4 gigahertz though? Like, would the 900 megahertz ones work fine?
Well, at least the XP ones I've used, right now, I've seen other people use the robo games. They have all kinds of trouble. But you're not going to have that kind of intense traffic, robots everywhere, flooding, flooding everything. So, but I like Bluetooth better.
I don't know, with Stephen's multi-agent systems and what Camilla is working on, I'm not sure if what you say is true, Michael. There won't be robots everywhere. Of course there'll be robots everywhere.
Okay. Yeah, there's going to be robots everywhere. It just some of the controllers that people use in robo games for the big battle bots are just big RC airplane and controllers, and some are from China. They just kind of broadband
Oh, jeez.
everything, cause all kinds of problems. But but like you said, yeah, there'll be robots everywhere, so we'll probably have to deal with that.
Yeah.
Maybe other communication methods other than just relying on wireless too.
Ooh,
I like the
yeah.
idea of sort of using some kind of sort of pinging, like binary back and forth or something, kind of like Morse code or something.
All right. Well, on that note, thank you everyone for joining in the robot party and showing your robots, telling us what you're working on, and your future thoughts about robots. It's been great fun, and I hope that for next time there will be lots of progress made, which will be great. Always great to work on projects. And yeah, thanks for joining in. See you next time, and thanks to the viewers for viewing as well. Until then, stay tuned to the Robot Party Rockstars group on Google Plus for the next one in August. Bye, everyone.
Thank you, everyone.
Bye.